Hello, I'm Dave Casler, amateur radio call sign KE0OG, your guide through the ARRL license manuals. The videos in this course follow the manuals section for section. You can get the ARRL license manuals from the source listed below the video. After you watch the video, dig into the corresponding section of the book, study the associated questions, and then come back for the next video. Now, the word propagation is very simple. It just means how we get our information over a radio wave from one place to another. How that radio wave leaves your antenna and goes to another antenna. It's really not a hard concept. It's just maybe we might use a different word for it. How RF travels. But the word is propagation. We might as well use the word that everybody else uses for it. Now, what happens is you've got an antenna and you've got a little RF source, which is your transceiver, and it's going up into that antenna, and it's going to go in free space over to somebody else's antenna. And some people will draw that as here's the transmitter, here's the receiver, and then draw a line in between. Well, actually your transmitter is transmitting in all directions, and there happens to be a receiver over here that's picking it up. Well, there could be a receiver over here that picks it up too. But in ham radio it's generally person to person, so we don't talk about the broadcast kinds of things. But it works on the same principle. Now, what an antenna does is it's specially designed so that it will resonate at the frequency that your RF energy is feeding into it. And through the magic of radio, what happens is that the energy in your radio wave leaves the antenna and becomes a disturbance in the electromagnetic field, which can be picked up by another antenna, which will then induce an RF voltage in the feed line and go back down into your transmitter. That's really all there is to it. Now, some interesting things about how different signals propagate. At VHF, let's take the 2 meter band, for example, which is 144 to 148 megahertz. What you have in there is waves that generally will only go line of sight. If you can see a mountain, say for example, and there's somebody up on that mountain listening to you, they'll probably be able to hear you. There are details, but in general that's true. Now, there is something in radio waves, they don't quite go line of sight. They can curve just a little bit. So if it's just beyond that mountain, they might be able to get you. Now, there's something called knife edge diffraction. It's just the way radio waves work. It turns out that radio waves are very, very much like light or heat or ultraviolet or cosmic rays or all of these other kinds of things which can be described as electromagnetic fields. And that is that if you have light coming in and it hits something very sharp, it will tend to kind of splatter on the other side. And in some places the splattering makes the signal add up, and in other places the splattering makes it cancel itself. And so you get this what's called knife edge diffraction. It has to go over a very sharp object like the edge of a mesa or something like that. Now, there are other ways. For example, like I live in a canyon, and the radio waves can hit this canyon wall, and end up coming to the receiver out of phase with each other, and they'll cancel, and that's called multipath or multipath distortion. That can happen too. Now, on HF we do something a little bit differently. The electromagnetic waves, or RF, will go up, and there is a layer in the ionosphere that is about 75 to 150 miles high. That's not really very high when you think about it. It's like the distance from, I guess, Boston to New York, but except vertical, up in the air. And it is literally in the air. It's the upper reaches of the atmosphere. And it's bombarded by all the junk put out by our sun. And what happens is that that energy knocks electrons off of the atoms of air that are up there. When you knock an electron off, that makes the remaining atom be positively charged, and that's a process called ionization. It creates ions, and that's wonderful to know that. But this layer is called the ionosphere, and there are different layers and they do different things, but fundamentally a radio wave takes off from your station, hits this, and gets bent back down to Earth. If the frequency is too high, it just keeps on going. Okay, there's a frequency where it'll be bent back down to the earth. And it turns out our HF bands, including the 10-meter band that you will be able to use as a technician, operate this way. Just a few days ago, I spoke with a station in Italy, and I'm in western Colorado. So what happened was my 10-meter signal on the band you can use went up, was brought back down by the ionosphere, hit the ground, was reflected up, and bounced several times. We call that multi-hop propagation. Now you may ask, where does the ionosphere come from? It comes from the sun. And for many years now, the sun's been quite inactive, no sunspots. But sunspots are like little storms on the sun. They look dark because they don't put out quite as much energy as the rest of the sun does, but believe me, they're very bright. What these sunspots do is throw out a lot of junk from the sun, and that junk, all charged particles, hit the ionosphere and kind of swirl around the Earth and charge that upper layer. In fact, if you're way in the north or way in the south, you can see the northern lights or the southern lights, which is that very thing happening. So that's all there is to it. When we have sunspots, we have good propagation. Otherwise, we don't. So read the chapter, and I think you'll do very well with it. It's pretty straightforward. Until then, this is Dave, KE0OG, wishing you good luck with your studies. We'll see you next time. Thanks for following along with the videos and the book. After you've studied this section in the manual and are satisfied you understand the questions and their answers, come back here for the next video. The ARRL is the National Association for Amateur Radio, and I urge you to join, even if you don't have your license yet. That way you get QST, the League's monthly magazine full of articles for beginners and veterans alike, or you can choose On the Air, a magazine designed specifically for those new to amateur radio. Until we next meet, 73.